Okay, everybody, welcome back to be determined, and I'm going to give you guys our intro to particles tutorial. After taking a little bit of time, I thought we'd do this in a slightly different way, where rather than you watching me type out the code in real time, I thought I would start with the code in one air quotes final state, and I'll explain line by line kind of what we're doing. Now, any Canvas tutorial we do is going to assume that you understand the basics of JavaScript, and there will be a lot of math involved whenever you're doing particle physics and that type of thing. Math is always involved. So, without further ado, we have what I've been affectionately calling our Big Bang simulator. Because if we leave this going long enough, right, we have an initial explosion of particles, not dissimilar to the Big Bang, but each one has a different velocity. And while at first it feels like it's just scaling, it's not scaling. This isn't getting any bigger. This isn't getting any bigger. Just things are getting further and further away from each other. And the things with the least velocity are the ones that are staying on the screen. So initially when I was just messing around with the particles, I'm like, ooh, that reminds me of the Big Bang. And I figured we'd leave it there. So this is all just vanilla JavaScript and HTML. There's nothing crazy, there's nothing special about it. So I'll just go through and I'll start by explaining the HTML. So first off, we have our body tag here, and I'll put this all in line just so it's easier to read. And we're giving it a style margin 0, padding 0. If this was a larger scale project, you would put that in a style sheet or something to that extent. But for now, I'm just inlining it. This is because we want the canvas to stretch to the size of whatever the screen is, and we don't want it to exceed, even though we can see it is exceeding a bit here. There we go. So we have our container that's here. Its width is 100 view width. Its height is 100 view height. We have our body, margin 0, padding 0, and we have our canvas here. And that can just be shortened here. So this is it. That's the HTML portion of this demo. So then let's get into the JavaScript. So the first thing is I want a variable that holds a query to the canvas on the web page. So that's what this line is here. Var canvas equals document.querySelector canvas. So basically, this variable is now this and all the DOM properties that come with it. I now make a variable CTX that stands for context. And I'll put that in there. You know what I'm going to do in post? I'm going to keep one of these pauses. This is going to be cool. I'm going to keep one of these pauses of her going da-da-da-da-da, and I'm not going to say nothing. And then I'm going to isolate that audio, and then I'm going to use Audition to remove that audio from the tutorial. Anyway. This is the context. The canvas context is really what... it's basically the draw mechanism. It lets the draw head know where it is, how big the canvas is, where to draw things relative to where they are, which is why, like, no matter what size this window is, this explosion will always start from the middle and go out. And that's because on resize, we're changing the context. We're adjusting the context along with resize, and I'll show you that in a second here. So I don't set the context out here, and you guys will see why in a second. I like having as little code as possible. The other thing that I like is making sure that my code is semantic, and this is something that we talked about internally in terms of helping people, especially for marginalized communities, but people in general. Like, there's no reason why your code can't be written in a way that is understandable for someone that, speaks English in any capacity. So we have num particles. That's the number of particles. That's the number of circles that are showing up on the screen every time we do it. We can increase this to 10,000, and you'll see, oof. But as they spread out and some of these get off the screen, the context no longer needs to worry about drawing them, and you'll see the performance speed up as more and more of them get pushed off the screen. Ooh, slowly increasing frame rate, and I think we're at full frame rate right now. So you can see how because the context is shaped to the screen. Before I refresh that, let me put it down to like 5,000 particles. The context knows when it's past the edge of the canvas, and therefore it doesn't have to worry about drawing the particles that go beyond the edge of the canvas. And so, this is like a hint of what's to come. We're not using gravity in this first example. That will come in the very next tutorial. Or maybe at the end of this tutorial. We'll see how it goes. So then, let's talk... Well, first let me finish talking about canvas, and then we can talk about objects. One second. I'm sorry. Okay, so Canvas is a drawing API for the web and for JavaScript and HTML. I mean, HTML, CSS, and JavaScript are all very closely linked. They're separate technologies. You can build a site with only HTML. You can generate a site using only JavaScript. You can just use HTML and CSS. But they're very connected. So, it's hard to say like, oh, Canvas is a JavaScript technology. It's a drawing API for JavaScript. But it also uses CSS. You can use CSS to style things inside of it. And you can use CSS filters inside of it when you're using a 2D context. And the Canvas tag is an HTML tag. So, you get what I'm saying? Like, it's not... I can't explicitly say it's a JavaScript drawing API because it's a HTML drawing API as well. Okay, so I'm going to assume everybody understands Canvas enough for me to continue. So, now let's take a look at the particle class or the particle object. So, I'm sure some people would be like, why are you trying to cram a lesson about objects and a lesson about particles in the exact same lesson? And I would simply say, because if you can conceptualize your particles as objects and that those objects have properties and behaviors, then it's a very... Wow. It's a very small leap from particles to sprites, and then from sprites to video games. So, I figured I should teach you guys classes at the same time. So, object-oriented programming is a concept in which you define your application in terms of objects and how those objects are related to each other, and also the concept of inheritance and how one object can extend another. And when it first came out, the intent was for it to be very semantic, and that means understandable by humans. And so I remember when I was 14, I was taking a course on small talk at Carleton University. And the example they gave, I need to plug in my headphones. The example they gave was a bank, right? Okay, well, I have a bank as an application. Well, what does a bank have? Well, a bank has customers, right? And a bank has accounts. But customers also have accounts, right? And so, where should the account be held? Well, the account's held with the bank, but the customer owns the account number, right? And you start conceptualizing your application into these various objects with properties and functions, and then you write your code in that way. So then if you think about a customer, well, a customer is a person, right? But a person isn't always a customer. So you might start with a person class, and a person has a name, an address, and a phone number. And then you can make a new class called customer. Customer can inherit person and will have all of the properties and functions of a person. But now you can extend it by giving that person an account number, an account balance, a credit card. And maybe it's just simply easy as window.innerHeight and window.innerWidth just at the constructor. And in all honesty, we don't even need to assign the canvas width here or height here. We can just take this right here and put it there, get rid of that, and change this to width. So
both inner height?
No, window.innerWidth divided by 2 and window.innerHeight divided by 2. And so let's just finish going through this. So we have the particle. The particle as the constructor. It's saying, hey, spawn me in the middle of the stage. That's the inner width divided by 2 will give you the middle here, and inner height divided by 2 will give you the middle here. Then we have, then we have the size, and right now we have it math.random plus 2, so the smallest a particle can be is 2. And then we have speed. So this is where I'm setting the speed for each particle.
This is Chase.
So, taking it from the top, now that we have things looking back kind of the way they're supposed to. So we have the start of our application up here, right, where we are defining our canvas. We have a context that we haven't defined yet. We're defining the number of particles, and we have an array called particles. And then we have an object or a class that we are calling particle. Now, you should have it separate from your primary application, right? Like, particles is an object, and then this is your application down here. So we have our class, then we have our application. So init is going to populate the array with particles, then process frames is going to reset the canvas width and height. Then it's going to define the context. So we're defining the context every time we process the frame because we might be resizing the canvas. And in future states, things like mouse events and mouse coordinates will become very important. And if you don't refocus or redefine the context of the canvas, those numbers will start becoming skewed. Then, yes, babies. So then we clear the canvas, clear rectangle, the canvas. Sorry, guys, I'll try to repeat that again. So we define the canvas width and height again. We then clear the canvas completely. And then for each particle in the particle array, we invoke the drawMe function. That was a long trip just to get to there. I'm sorry. I'm very sorry. We should have gotten there in 10 minutes, and instead it's taken us a half hour. So then every time a frame is processed, it draws, as we previously stated. It creates the gradient and it draws it. So then we have request animation frame. Request animation frame is a function built into JavaScript that at approximately 60 frames per second will fire off whatever function you put in here. In this case, process frames. So it becomes a recursive function. This is basically your engine to do anything. So as we expand on this tutorial and we get into things like particle behaviors and we get into things like hitboxes and other things like that, all of those functions will be invoked from this process frames function. So that's the code base as it is. I'll kind of slowly pass through it again so everyone can see what's here. And then again demonstrate the way it looks. So we'll do another tutorial tomorrow in which we add gravity and bouncing to these particles.
Apple juice!
But we're going to end that right here.
Can I have a drink of apple juice?